Ladies and gentlemen, boys and girls, children of all ages.
Welcome.
Today we continue adding and subtracting fractions. Adding and subtracting fractions. Let's talk a little bit about what we have to be able to do to add and subtract fractions. It's a lot, but it's not difficult. You just have to remember what you have to do. So the first thing we have to do is you have to have a common denominator. Okay, so we first have to have a common denominator. So let's look at this problem. 2/5 plus 3/7. 2/5 plus 3/7. Well, Mr. McMurdo, you said we had to have a common denominator. How in the world do we do that? Well, let's find our common denominator. Now, we want to find the least common denominator. Makes it easier. Because, we could make this 70 or 140 as our common denominator. It could be 210. Well, we want to use the smallest number we can possible because it makes it less to have to simplify. So this is how we find our common denominator. We're going to list our multiples of our denominator, which is 5 and 7. And we're going to go down our multiples. So sometimes it's called the least common multiple. We're going to go down our multiples until we find the first one they have in common. 10, 15, 20, 25, 30, 35. Now, because I have done this for so many years, I knew it was 35 before we got going. And the more you add and subtract fractions or you find common denominators, the more you're going to get where it's easy. And again, Bree's smart. Bree's using the multiplication chart because she has 5 and 7 on her multiplication chart. And she knows if she was taking some test for some reason, she could get some graph paper and draw a multiplication chart. Okay? Smart. So we have our common denominator. Our common denominator, the first one they have in common is 35. Now, while I was gone, you had an assignment a worksheet where you had to fill in the missing part of a fraction. Now, not all of you did it, but it was assigned. It was assigned. So now we have to change it. We have to make them equivalent fractions. With the common denominator. And this is what I'm doing here. I'm going to make them equivalent fractions with the common denominator because I don't want to change the value. I don't want to change the value. So then I got to ask, what did I multiply by 5 to get 35? Anyone?
7.
If I multiply the denominator by 7, I must also multiply the numerator by 7. And so my new numerator is?
14.
What did I multiply by 7 to get 35? 5. If I multiply my denominator by 5, I must also multiply my numerator by 5. My new numerator is? 15. Now the third thing you should always do, and I saw this on yesterday's warm-up, is check the sign. Check the sign. This problem is an addition problem. We know once we have the common denominator, that's going to be our denominator. I don't have to change that. Yes, ma'am. Oh, what is it? 14? 29. And last thing we have to do is we have to put it in simplified, lowest terms. Meaning, no improper fractions, and the fraction itself has to be simplified. No improper fraction, and the fraction itself has to be simplified. How do we do that? Well, we're going to find the greatest common factor. Is this an improper fraction? No. So to do that, we could find the greatest common factor. in finding the greatest common factor, we just list all the factors of each number. Now we always start with 1 and the number. So 1 in 29, 1 in 35. What other factors does 29 have?
Nothing.
Nothing. So what kind of number is it, Michael? Good. Prime. If it only has 1 in itself as a factor, that number is a prime number. 35 obviously has 5 because it ends in a 5. And 7. Any others? Adam, what kind of number is 35?
Composite.
Composite is correct. Now we look what they have in common. They have a 1 in common. Do they have anything else in common?
No.
No, they have nothing else in common. If your greatest common factor is 1, that means your answer's already in lowest terms. All right, that's a bunch of not hard stuff. That's a bunch of stuff to do to solve one problem. A bunch of stuff to do to solve one problem. But none of it is difficult. Y'all know how to list the multiples. That's easy. Y'all know how to make equivalent fractions. That's easy. Y'all know how to list, you all know how to add or subtract. That's easy. Y'all can find the greatest common factor. That's easy. None of it is difficult. It requires work. I'm just saying.
Saying what?
That none of it is difficult, it just requires work. Let's see here. We'll just wipe that out. And then we're going to do 11/12 minus 7/15. 11/12 subtract 7/15. Do we have a common denominator?
No.
No, not yet. So I have to list my multiples for 12 and 15. 24, 36, 48, 60, 15, 30, 45, 60. So my common denominator is 60. Y'all, I mean, if I didn't know that 15 times 4 was 60, I mean, I could just, 15 times 1 is 15. Add 15 more is 30. Add 15 more is 45. Add 15 more is 60. I mean, so, not difficult, even though it's not 1 on our multiplication chart. Now I'm going to take my least common denominator, which we said was 60. I'm going to make the fraction 11/12 multiplied by something. 11/12. Joel, is that closer to a half or closer to 1? 1. Closer to 1. Because that's like if I put 11, or if I put 12 pieces of candy on there and Joel eats 11 of them, he ate almost all of them. Joel, you're going to get a cavity.
Cavity?
All right, now I can go back over here and I can see, what did I multiply by 12 to get 60? 1, 2, 3, 4, 5. So 12 times 5 is 60. If I multiply my denominator by 5, I must also multiply my numerator by 5. And if you can't get this, it makes me crazy. 11 times 5 is 55. What did I multiply by 15 to get 60? I can go 1, 2, 3, 4. If I multiply my denominator by 4, I must also multiply my numerator by 4. My new answer is
28.
Now I go back and I check my sign. My sign is subtraction. I know it's going to be over 60, but now I need to subtract 55, subtract 28, and that equals
27.
what? Madison.
27.
Are you Madison?
Yes.
Maddie R. Good, 27. Thank you. So now we have to see if this can be simplified by finding the greatest common factor. Well, I'm going to use a little bit of my divisibility rules, because that's going to help me so I don't have to do all the all the factors of each one. Are they both even?
No.
No, so they can't be divided by 2. Anybody remember my divisibility rule for 3?
It's over there.
If the sum of the digits is a multiple of 3. So what's the sum of the digits in 27? 9. Is 9 a multiple of 3?
Yes.
What's the sum of the digits in 60? Is 6 a multiple of 3?
Yes.
That means these both can be divided by 3. 27 divided by 3 is what, Giovanni?
9.
No! Giovanni? 9. Oh, for the love of Pete. Michael, 60 divided by 3 is?
20.
I am going to have to punch all of you in the nose. All right, 9/20ths. We don't know if that's simplified yet. Are they both even?
No.
Can they be divided by 3?
Yes. No.
Not both of them.
Not both of them. Yes.
Okay. 5. Do they both end in a 5 or a 0? 6. We already said they can't be divided by 2 or 3. 9. Are the sum of the digits a multiple of 9?
Yes. No.
No. Well, we can figure it out with our divisibility rules. Let's list some. 1 times 9, 3 times 3, 1 times 20, 2 times 10, 4 times 5. What's the biggest one they have in common? 1. If 1's the biggest they have in common, then that answer is in lowest terms already. It's a lot of work. It's a lot of junk we have to go through. But none of that junk is difficult. This is why I asked you to show all your work on the warm-up yesterday. It's why I made you turn in all the work on the warm-up yesterday. Because if you don't do all the work, you have a 79% chance of getting it wrong. I'm just saying. All right, classroom of Google, go.
Riley. 100%.